Hello everybody, and welcome back to the continuation of example 1. We are still looking at page 68 in the workbook, and hopefully you gave it a try to calculate the right cosets. Okay, I've gone ahead and showed you the calculation that I did for the right cosets, and what did you notice when you did this? Okay, I'm hoping that you noticed that the left and the right cosets are exactly the same. We got the same 4 sets there. That's a very important observation, so I'm just going to write that down. Okay, and there's something else interesting that we can notice here if we look back at the Cayley table that we have for our group. Okay, so what we're going to do is to take our elements and kind of group them together, okay, by drawing some lines into our table here. And by doing this, we're kind of grouping our group elements into groups of 2. Okay, and what I'd like you to notice, if I start circling those groups of 2, notice that those are exactly the 4 cosets that we calculated, the left or the right cosets. The same thing happens over here. Okay, and even more interesting than that is what happens if you think about the question, could we multiply 2 cosets by each other? Okay, for example, what if we took the coset that contains H and V and multiplied it by the coset that contains R90 and R270? Okay, well, if you multiply those together, you get 4 elements, and you notice that really it's only 2 elements, D and D prime, because they're repeats. So you could say then that when you take the coset HV and multiply by R90, R270, you get the coset that contains D and D prime. That's on our list. Okay, let's try that experiment with another 2 cosets. What if you took the coset containing D and D prime times itself? What you would get is the coset that contains R0 and R180. That's sitting right here. Okay, so we've got sort of a closure going on. If we think about multiplying 2 cosets together, we get another coset. Okay, another thing that's interesting is what happens if you consider the coset that contains R0 and R180. If you multiply that by any other coset, you get the same coset back again. Okay, so R0, R180 times HV gives us the 2 elements H and V. So R0 and R180, that coset is behaving like an identity element. Does this behavior remind you of anything that you've seen before? Okay, it looks like these cosets form some sort of a group. Okay, I'm going to write that down. Okay, so it suggests that we can regard the set of cosets themselves as elements of a group. Okay, in particular, we would be talking about a 4-element group because we've got 4 cosets, and I'm going to write those down. R0 in K1, R90 in K1, H times K1, and D times K1. That's a group of order 4, okay? Kind of suggested by the Cayley table that we talked about above. And this group that we're talking about has a special name. It's called a factor group, because the elements in it are actually cosets. And that's really the topic that we'll be exploring in detail as we work our way through this chapter.